Example 2. A young boy collects silkworms, which on average live for 52 days. Each female silkworm dies almost immediately after laying about 300 eggs. In breeding conditions, about 35% of eggs reach maturity, and female silkworms account for 70% of the population. If the young boy has been given 3 female silkworms, determine the silkworm population after 1 generation. Right, so we would assume then that F0, the female initial population, is 3. So population 1 then will be those 3 females times the 35% of the eggs that reach maturity, and multiply that by the 300 eggs that each female produces. We don't use the 70% females here because we're given that there are 3 females. So those 3 females already represent 70% of the silkworm population. Right, so this gives us a value of about 315 silkworms. B. Create a Malthusian difference equation and calculate the number of silkworms the boy has after 1 year. So they're asking us to use this format now, where we have population n plus 1 is equal to 1 plus the intrinsic growth rate times the previous population. So we have to work out R here. So remember that R is given as the birth rate minus the death rate. Right, so in this case, the birth rate is given as a decimal, 73,5, which would be 7,350%, minus the death rate, which is given as 1, expressed in decimal form, which is 100% of all silkworms will die. So that 73.5 does seem really high if we look at it in terms of 7,350%, but remember that there are 300 eggs per 1 silkworm that is laid. So the growth rate is extremely high. So that gives us then a growth rate of 72.5. Now you could look at this as saying 7,350% minus 100%, which would then give you a growth rate of 7,250%. But we generally work in decimal form only. So we know now that our difference equation is going to look like this. 1 plus 72,5 times the previous population. So what we have to work out now is how many populations or generations there will be in a period of a year. Now I know that we discussed that a silkworm, if you keep them at home, they lay their eggs sort of towards the end of spring, and they only hatch the following spring. Now that's far from ideal conditions. In the wild, they would hatch almost immediately. So within a 52-day cycle, the eggs would have probably hatched already as the mothers are dying. So in these questions, it's always key to take this 52 days as what the life cycle is. So we know that there are 365 days in a year. If we divide that by 52, we get a value of 7,019, which we can round off to 7 generations. So in other words, we're trying to discover how many silkworms there have been after the 7th generation. Or in other words, how much he has at the end of 1 year, provided that they all stayed alive. The last population, that is. Right, so we now know we've already got population 1 in point A. We worked out that population 1 was 315 from the initial population of 3. So now we're effectively working out population 2. So population 2 would equal 1 plus 72,5 of population 1, which was 315. So at this point, you put 315 on your calculator, 315, and you put that into memory. And we then say brackets 1 plus 72,5, close bracket, times your answer, and we get population 2 equal to 23,152,5 silkworms. Obviously, we know that's not accurate or exact, but we use the number until we round off at the end. So we've got population 2. We press equals, we get population 3 equals, population 4 equals, population 5 equals population 6 and equals population 7. So population 7 is 4,966 times 10 to the 13, which we can round off as 5 times 10 to the 13. It's not even really necessary to round that off, but it just makes for a more round and pleasing number to look at. Right, for question C, each silkworm eats about 90 grams of mulberry leaves in its lifespan. How many kilograms of leaves will the boy need to pick to feed all his silkworms in the first year? Okay, they've said that each silkworm eats about 90 grams, but the answer wants us to give it in kilograms, so we need to convert that amount into kilograms, which would give us 0,09 kilograms. Right, and so, because we've worked out in the previous question that by population 7 there will have been 5 times 10 to the power of 13 silkworms, we need to say that this is 5 times 10 to the power of 13 times 0,09 kilograms, and that gives us a total of 4.5 times 10 to the power of 12 kilograms using the calculator. At this point, your answers to B and C should be proof to why this model is actually a bit unrealistic, because there are many, many other factors that would come into play, particularly if you're keeping silkworms as pets, because there's very little light and a whole lot of other factors as well. But in the wild, there's a lot more other environmental factors, such as being eaten by birds and things like that, that it would just not be possible to have this amount of silkworms, and it would also not be possible to have that amount of mulberry leaves. 4.5 times 10 to the power of 12 kilograms is equal to 4,500,000,000,000,000,000. So you can see that is an impossible number of kilograms to have.